Ladies, gentlemen, boys and girls, children of all ages, welcome to Variables and Pattern Rules. Mr. Benjamin here, smiling as always, happy to be alive. This is our second video. That face kind of looks angry. Let's make those eyes a bit bigger. Yeah. And the eyebrows. Hey, happy. So this is our second video in our patterns section. Now, our previous video looked at normal number patterns, whether they be through addition or multiplication, or you are going in the opposite direction with subtraction and division. But most of the time they were only one operation. For example, if we remember Pascal's triangle looks a little like this. I'm going to do a really quick interpretation of it. 1, 1, 1, 1, 1, 2, 1, 3, 3, 1, 1, 4, 6, 4, 1. It looks very, very strange until you realize there are several patterns going on here. This first row, this is all ones. Okay, so that's not much of a pattern there. They're just constantly 1. The second row, we're going up by 1 each time. 1, 2, 3, 4. 1, 2, 3, 4. And in fact, the number after that, I'll write it in here, this is a 5. This is also a 5. I also just remembered that you can't see this area down here. So what I'm going to do is, I'm going to move this. Oh, no. I'm going to do something. I'm going to erase my name first. That's scary. I'm erasing my own name. Where did Mr. Benjamin go? Now, what I'm going to do is, let's try that again. I'm going to copy this. I'm going to move it over here. Will that work? Nope. That's a disaster. I apologize. You know what I'm going to do? I'm going to erase this whole thing, and I'm going to draw it again. I have successfully managed to waste 2 minutes. I apologize. 1, 1, 1, 1, 1, 2, 2. Nope, I did that wrong as well. 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. All right, back to it. So we still have that pattern. 1, 2, 3, 4 on this side. 1, 2, 3, 4 on this side. These are all ones. These are all ones. But those patterns, we're not going to be looking at those patterns. We're going to be looking at a different pattern. If I take these two ones here and I add them together, I actually get that too. And if I take these values here, 1 plus 2 equals 3. Same with these values here. 2 plus 1 equals 3. 1 and 3 make 4. 3 and 3 make 6. And so on. So, without further ado, which I've never understood, our learning goals for this video. We are going to use numbers, not hashtag, use numbers and variables. That's a new one we haven't looked at yet. We'll define that later. To represent mathematical relationships. We're also going to find different ways to describe a pattern. So, our definitions. A variable is a letter or symbol that can represent a number. This can literally be any letter or any symbol that can represent a number. So, for example, I have X, N, A, B. You could literally use smiley faces if you want. You could use sad faces. You could use water bottles. I don't know. I'll draw a quick water bottle here, I guess. Not really much of a water bottle. But, you know, you can use any symbol to represent these variables. And we're going to be doing that today. You have to keep in mind, though, that these symbols, letters or symbols, represent a number. Okay? And it can be any number. Algebraic expressions. A combination of one or more variables. And this can include signs of operations. And remember, our signs of operations are addition, subtraction, multiplication, and division. And a constant is a number that doesn't change. The word constant means the same, right? So that constant will never change. Examples, n plus 1. Well, a lot of you are going to look at this and say, well, what is n? How can we know what n is? That's the thing. N is our variable. Meaning, this can be any number. Any number we want it to be. So if I gave you this rule, this pattern, n plus 1, you would tell me, well, your first value, if n equals 1, n plus 1, and we sub in 1 for n, 1 plus 1 equals 2. I'm going to erase that, and I'm going to say if n were to equal 2, n plus 1, but we'll make n equal 2, 2 plus 1, that would equal 3. I'm going to erase that. And how about if n was 17? N plus 1, but we're saying n is 17, so it would be 17 plus 1. That would equal 18. So you can use this to find any number. So if we were to ask for the 100th term, the 100th number in this sequence or series, we would literally just say n plus 1, let n equal 100. You would have 100 plus 1 equals 101 instead of n plus 1. Another example. This might look strange to you. You might see 2 multiplied by plus 1. But the reason why I have x, this x here, it's different. It's kind of shaped weirdly. It's not like that. It's not a star. It is a curved x. This is a variable. In our last question, in our last example, we had n plus 1. We said n was our variable. In this example, we're saying x is our variable. And it's not just x, it's 2x. And whenever we have a value like that, 2x, oh, that was bad. Let's try that again. What we say is, we're going to put a little dot right there. This actually means 2 multiplied by x. And remember, since x is a variable, this can be any number. Okay? Keep that in mind. Variable. Go back to the definition if you have to. A letter or symbol that represents a number. Back to it. So, if we want, say, when x equals 5. I'm actually going to get rid of this 60th term here. I'll come back to that. So we have 2x plus 1. But we're saying x equals 5. So we're going to put this 5 right here. 2 multiplied by 5 plus 1. And we'll get 10 plus 1, which equals 11. If we said, or if we wanted to find out what our value is when x equals, I'm going to write that again, equals 60. Same idea. We're going to write out our equation again. 2x plus 1 to 60 plus 1. And this means 2 multiplied by 60, which equals 120 plus 1, which gives us an answer of 121. So this might seem like a lot now, but the more you do it, the easier it becomes. You just have to remember that this x value, this right here, can be any number we want it to be. Sometimes you're going to get examples where you have figures and you have to figure out what the pattern is. So in this example, we're going to look at it. We're going to see that we always have a face. We always have a smiley face. And it's always the same smiley face. Okay? This face is a constant. All right? It never changes. Doesn't matter if it's figure 1, figure 2, figure 3, figure 4, figure 5. It could be figure 1,000. Or figure 2,000,000. It will always have this same face. I can't redraw it again, but it'll always be that same face. Okay? Now, getting rid of all that. So, we label constants as plus 1. Because no matter what, you're going to have that one face. I'm going to keep that plus 1 right there. Now, let's take a look at what's different in each figure. If we look at figure number 1, we have 1 blue star. Figure number 2, we have 2 blue stars. Figure number 3, we have 3 blue stars. 4, we have 4 blue stars, and so on, and so on, and so on. So the number of stars is equal to the figure number. 1, 2, 3, 4, 5. So what we can say is this pattern is actually very similar to one we've already looked at. N, or in this case, you know what, let's use F. Rule equals F plus 1. So in figure 3, for example, we have F plus 1, 3 plus 1, and that equals 4. And if we look at figure 3, we have the one face, 2, 3, 4. 4 figures. If we wanted figure, let's do figure 76. F plus 1, but we know F will be 76. 76 plus 1, and that'll equal 77. Any number we want to put into that variable. We can take any number. That variable represents any number we want. So, try this. I want you to create your own rule with images, okay? So you can use squares, triangles, happy faces, sad faces. I can't draw a dog, but maybe a dog, cat, animals, pets, whatever you have. Use any symbols, any figures, and create your own rule, okay? This rule, we're going to get together and we're going to try to find out each other's rule. I think it's going to be a lot of fun. So, using my gray spray paint marker, I'm going to say thank you. And I hope everyone has a great night.